today, we're finding special products, but we're trying to find a shortcut. Nothing says that you still can't use the long way, do all four multiplications. But we have special products when we talk about multiplying a binomial times a binomial, and it's really nice if we can recognize when we have those special products. So we just did some binomials times themselves, and we figured out that, you know what? When you have a binomial times itself, you will get a squared. You will take the first term and multiply it by itself. So the first term in this one is a. This is just the algebraic way of talking about it. We decided that if you take the last term times itself, you will get the last term of our trinomial answer. And then Emma said, oh, you can just take the first term times the last term and then double it. Take it times 2. Well, that's what 2ab is telling us to do. So would you take your highlighter and highlight that better? The copier didn't do a good job of keeping that highlighted for me. So in other words, we can identify what is the first term. That's what they're doing over here with this problem right here. What is the first term? What's your a value? What is your last term? What's your b value? And then instead of doing 4 multiplications, really you just end up doing 3. 1, 2, 3, and you'll have your trinomial answer. Now the other thing that is important is that we remember we noticed that when there's addition in the binomial, it will be plus plus, won't it, in our trinomial. When it's subtraction in our binomial, it will be minus plus. So in other words, highlight this other one down here. When we have a binomial times itself that has subtraction in it, this is going to be the model for our trinomial answer. A squared, take the first term times itself, double the first term times the last term, and subtract that, and then add the last term squared. 3 multiplications again. These are called perfect square trinomials. You might want to highlight that too. Perfect square trinomials, we call these. Not every multiplication is going to become a perfect square trinomial. When you're taking a binomial times itself, you should get a perfect square trinomial. Okay? So let's go down here and do some looking to see if we can tell whether the product should be a perfect square trinomial or not. Look at number 1. What do you think?
Yes.
Yeah. Why?
Because it's a binomial times itself.
Yep, it can be written like this. As long as you can write it the shortcut way, x plus 5 squared like that, if you can write it like that, you know you have a perfect square trinomial. When you multiply that out, you can, or if you want to use the shortcut, this would be one you could shortcut. Do 3 multiplications instead of 4. How about number 2? No, we can't do that one because one has addition, the other has subtraction. Even though they both start with x and they both end with 2, this does not qualify as a perfect square trinomial. So we would say not a perfect square trinomial. And we will have a name for this one. This is also a special product. It was the 3rd problem each of you did in our row problems. We have a special name for those guys too. We'll do that on the back. How about number 3?
Yes.
Yes, because it can be written as 5x minus 6, that binomial, times itself. It can be like that binomial squared. So we would say its product would be what?
Perfect square trinomial.
Yeah, this one would also give us a perfect square trinomial. So once we decide it would give us a perfect square trinomial, then the only other decision we have to make is, would it be a plus 2ab in the middle or a minus 2ab in the middle? When do we have a plus 2ab?
When it's a plus.
When it's an addition in the binomial. When do we have a minus 2ab?
Subtraction.
When it's a subtraction. Okay, so let's go and practice kind of like in detail here. Number 4, we have x plus 7, that binomial being squared. So that should give us a perfect square trinomial, right? What's the a? X. What's the b? 7. So in other words, when we use our model, a squared plus 2ab or minus 2ab plus b squared. So we're going to square a. Do we need parentheses around that x? No, it's the only thing being squared. It's okay. We need to take 2 times our a value, which is x, times our b value, which is 7, and what are we going to get? 2 times 7 is 14, and 14 times x is 14x. And then we're going to square our b. What's 7 squared? 49. The next thing you want to do, always, is zero in on this. Because that's going to tell you when you put the first term down and you're ready to write the next term, that 14x, are we going to add it or subtract it? We're going to add it. And we always add the last term, don't we? Because we said a positive times a positive is a positive, and a negative times a negative is a positive. So this is our perfect square trinomial answer. Questions? Okay, in number 5, this one does have subtraction. So sometimes, many times I say to you, change subtraction to add the opposite. We're not going to in this case. We're going to leave it subtraction because we recognize that we have a binomial times itself, so this is one of our shortcut ones. So we're going to say our a value is what? X, and our b value is going to be 1. No, we're just going to be 1. Remember the model that says a minus b up there? What did they say the b was in that one? Let's look at it. In this one, it was 4x minus 3. They said a is 4x. And notice they said b is 3. They did not give it the negative sign, did they? Okay? So we're not going to give that 1 the negative sign. We're going to just let that subtraction stay a subtraction. So we have a that has to get squared. We double a times b. What do we get? 2x. And we square b, which is 1. We have our 3 terms of our trinomial answer. The only decision we have to make is, what should that middle term be? Subtraction or addition in front of it? It should be subtraction. So again, remember I talked to you about this already. When we are multiplying these, keep making connections to what the answer looks like, to what the problem looked like that you were multiplying, because you're going to, next chapter, do the reverse. They're going to give you this trinomial and tell you to get it back to x minus 1 squared. Okay? You're going to be able to do it, trust me. Okay, let's look at this last one. Go ahead and do this last one, number 6 on your own. Filling in the a, the b, the squaring, doubling, squaring again, and your final answer. I did something wrong there. Anybody want to tell me what it is? What? Great. I didn't square 2x squared. What did I square? Just the x. I have to make sure I square the whole a term. So those parentheses are super important in this one. 2x has to get taken times itself. So the first term of our trinomial is what, class? 4x squared. The second term of our trinomial is 40x. The third term of our trinomial is 100. We have addition in our binomial. So what does that tell us?
So
We're going to be adding that middle term. So it's plus 40x. We never have to decide about the last term. That's always add, right? Okay. So again, if you force yourself to learn this little rule and shortcut, it's going to help you in chapter 7. If you never do, you're still probably going to be able to, for the most part, do what we need to do, but you're just going to have to work harder. Okay, so questions at this point? Okay, can we use this shortcut for number 7?
yes.
Okay, because
It's a binomial by times
it's a binomial times itself. So if you don't want to write down what A and B is, I'll let you leave that part out. Maybe by now you've got that down. You could say, I have to do 3 multiplications though, right? So we have to square x. We have to take 2 times x times 8. And we have to square 8. So in your homework, there I'm going to go through it with you and say half of a group of problems you have to show at least this much work, and then the other half, if you're like, I could do this in my head, I don't need to show that stuff, then I'll let you just give the answer. X squared is x squared. 2x times 8 is 16x. 8 squared is 64. What's going on in our binomial? Subtraction. So x squared plus 16x minus 16x. Minus 16x. There's a subtraction in our binomial. And then what? Plus 64? There's our perfect square trinomial answer. Okay, you do number 8. If you want to identify A and B, you may, or you may just go into showing your 3 multiplications. And if you would rather show your 3 multiplications horizontally, I'm okay with that. So I'll show you what I mean by that. It's just that then you got to decide right away what that sign's going to be. That's showing it horizontally. But if you show it horizontally, then you have to make the decision right away. Should I add that second term, or should I subtract that second term? Do you agree with me? You have the same answer? Same product? Okay, now try number 9 then. Remember, do we treat the b value as negative ever? No. So the first term of our trinomial is 14x squared. 7 squared is 14.
49.
Ah, 49x squared. Middle term is? Well, you know what? Multiplication lets you multiply in any order. Do 2 times 5. What's that? 10. And 10 times 7 is? 70. Okay. And our last term is? 25. Okay. So it's going to be 49x squared minus 70x plus 25. Okay, you have to work a little harder at these special projects than the next ones we're going to do, but before we move on to the next ones, are you sure you don't have any questions on these guys? No questions. So when can we use this?
As a binomial times
Binomial times itself, not just any old binomial multiplication. It has to be a binomial times itself. The binomials have to match exactly, okay? So let's go to the back side then, and let's talk about, well, what happens when they don't match exactly? It is not a binomial times itself, but they both start with the same term. They both end with the same term. It's just that one has addition and the other has subtraction. Well, when we discovered that pattern, go ahead and highlight. I also want you to highlight this part. We call this the difference of squares. Difference of squares. This is the special product name for these. These are my favorites. When we have the same first term, same second term, and binomial multiplication, one's got addition, one's got subtraction, we don't have to work very hard at all. We square the first term, we square the second term, and we set it up as a subtraction. Why can we just ignore the other multiplications? What happens in the other multiplications if we were, let's think about foiling it. What would happen when we FOIL? If I took A plus B times A minus B, I want to just concentrate on the O and the I step. What would the O step be? A times negative B. What's that? What's that? Oh my goodness. A positive times a negative is a negative, and A times B is AB. And the I step would be B times A, but algebra says let the A be first.
Cancel each other.
And they cancel each other out. They are opposites, aren't they? So that's why we don't even have to worry about the middle terms. We get to just say do the first multiplication, the last multiplication, and you put a subtraction. Okay, let's decide what kind of special products we have in each of these 10 through 12. Number 10. Would our answer result in a perfect square trinomial or difference of squares?
Difference of squares.
Because one's adding and one's subtracting. Yep, they start with the same thing, they end with the same thing, but one's got addition, the other's got subtraction, so this is the difference of squares. We get to do 2 multiplications, is all we gotta do. How about number 11? Because
It's a binomial times itself.
it's a binomial times itself. So we would get a perfect square trinomial. That's the shortcut we could take for this one.
12.
And how about 12?
Perfect square trinomial.
Because
It's a binomial.
it's a binomial that can be written squared, right? So it is a perfect square trinomial. So the first thing we have to do is we have to be able to recognize what kind of special product we have. But we also have to remember, this always scares me. Once I introduce this, then we start thinking we can do it for any multiplication of binomials we want. This is only special cases, isn't it? Okay? So let's look at number 13. Would 13 result in a perfect square trinomial or a difference of squares? Difference of squares. Our A is what? A. A is A in this one. B is 7. So we get to do this. Square the A, square the B. A squared minus B squared would be A squared minus 49. Simple as that. We get to skip those 2 middle multiplications, don't we? Okay, how about in number 14? Perfect square trinomial or difference of squares?
Difference of squares.
A is 2, B is 3. 3m. Okay, square A. Square B.
9m squared.
9m squared, because we have to put that 3m in parentheses, because it's 3m times 3m, right? So 9m squared, so what would our answer be? Subtraction fussy. 4 minus 9 squared. Yeah, we have to write it this way. The a squared minus the b squared. That is not in standard form, I get that, but that's okay today. Okay. In special products, it's okay because we want to be able to see that we have the difference of squares. So we don't want to change it to an addition problem, okay? That's what we would have to do to put it in standard form. Okay, you do number 15 on your own. Well, you don't have to remember what this is. What once we, practiced identifying A and B, you can ditch that part if you want, and you can just show the 2 multiplications you got to do, and set up the subtraction problem, right? That would be showing it the vertical way. Why could I do that? One has addition, the other has subtraction. They both start with the same thing, they both end with the same thing. They almost look like the same binomial, but they have different operations. Showing it the horizontal way, this one we would show 10 squared minus 2x squared. And 10 squared is 100. And 2x squared is 4x squared. Okay. Easy enough, right?
I feel like it's a lot easier to do.
Wouldn't it be nice if all of them were special products?